right, in this example, we're going to find the inverse graphically. So we're given a graph of a function. So this graph right here is the function f of x. And we want to graph the inverse, which is called f minus 1 of x. Right? So we go with the concepts. This needs to be 1-to-1, and you can check because it passes the horizontal line test. And you need to switch x's and y's. So for each xy in your original function, then these switch around and the coordinates reverse. Right? So this becomes your like new xy. Okay, so the best thing to do is to find some points on this graph. So for example, this point right here is x is 3 and y is 4. This one here is x is 0, y is 2. This one is -1, 0. This one is -3, -1. And this one is -5 and -3. Okay? So basically, I'm going to reverse all these. So this, we're going to switch, is going to become 4, 3. So 4, 3 is over here. This one is going to become 2, 0. Right, so you switch this over, switch the x and y values. This one, -1, 0, becomes 0, -1. All right, -3, -1 becomes -1, -3. And -5, -3 becomes -3, -5. All right, so you look at each point you identify on the function graph, you flip the x, y values and you graph them and connect them with little line segments to make the graph of the inverse. All right, so we have this. So this is the graph of the inverse function there. Okay. What I want you to notice is that there's symmetry. The function and its inverse are symmetric on across this line, the diagonal, y equals x. Okay, so this is the y equals x line, where all the x and y values are the same. The function and its inverse, if you fold this along that diagonal line, they're going to fall right on top of each other. They're perfect copies, perfect mirror images.